Happy whatever day of the week it is when you're watching this, everybody. Today we're going to be talking about queues, alright? So let's get started. Alright, so we're first going to create a new file, and we're going to name that queue.java. Now, in case you haven't read this, a queue, much like the stack that we learned about before, is a data structure that allows us to store elements which follows a particular order. All right. Now, a stack was first in, last out, or last in, first out. However you want to. It's the same either way. And I like to say last in, first out, which means that whatever the most recent element was put in that data structure, the stack, that is going to be the element that is returned if you perform a pop operation. For a queue, it is first in, first out. And you can think of this like waiting on a line for, let's say, for a register at the supermarket, or when you would wait in line as a kid going from your classroom to your gym class, whatever. It's just waiting on a line. And so the first element that goes in on the line is going to be the first element that pops out should a pop operation, or for queues it's called a dequeue operation, is requested. All right, so let's get started. We're going to create a public class queue. And just like in the stack, we are going to need to use our private class node. Now, the node we're going to be using is going to be slightly different than the nodes we've used so far. It's going to have one extra member variable. All right. And the reason why is because we're not using a linked list like the ones we've been using before to create a queue, because those linked lists were called singly linked lists. The reason they're called that is because they have a single link from one element to the next. What we're going to be using now is called a doubly linked list, because there will now, each node will have two links, one to the next node in the list, like we had in our singly linked list, but also a link to the previous node in the list, so that we can traverse back and forth throughout. All right. So we're going to create these three member variables: int value, node next, and also node prev, short for previous. All right. Just like normal, we're just going to have a single constructor, and that will be that parameterized constructor that we're going to use because no one else is using our class. So, why not? We just have to use this correctly. And when they give a integer value v, we'll set our value equal to that integer, and then next will be null. Oh, why did I put a semicolon there? Next will be null. There should be an equal sign. That's what I missed. And previous will be null as well. All right. So that's our node class. Sweet and simple. All right. Now, if you, hopefully you read this, but if you read the diagram over here, we have four main operations that we want to be able to use on this queue. Enqueue, which adds an item to the queue. If it's full, then there's an overflow condition. Whatever. Dequeue removes an item from the queue. The items are popped in the same order in which they are pushed. If the queue is empty, there's an underflow condition. And front, just return the value of that first element in the queue without actually popping it off. And rear, return the value of the last element in the queue without actually taking it off. All right. So, first, before we do that, we need to understand what our queue needs to do this. So we need our member variables for the queue class. And we'll be breaking this over a few days, guys, so don't worry if you're not getting it all right away. I'm trying to make it so that you guys aren't getting too killed on the work. All right. And so what we need for this class, we need a node that represents the head of the line, right? we also need a node that represents the tail of the, I said line, of the queue. All right, so the head is the next in line, you know, the next, the thing at the front of the line, and the tail is the thing at the back of the line, you know, the integer at the back of the line. So we're always going to be popping off from the head and, you know, adding on to the tail. All right, now our size is going to be equal to 0 at this, oh, sorry, and we also need a size. I'm jumping ahead of things. Ah, man. Mr. Sands just made a gaffe, a goof. All right, so let's just do the constructor, and we'll do Q and NQ and DQ tomorrow. All right. So for this public constructor, this will be our default constructor for the class. What we're going to do is we're going to say, all right, the head should start at null. The tail should be equal to the head because, well, they're both null. They're both pointing to nothing right now, so that should be fine. And we can say our size starts at 0. All right, so this is an empty queue. All right, now, you know what? We have time. We're only 6 minutes deep. Let's do the NQ. All right. All right, so now we want to, this gives us an empty queue. What if we wanted to add to that? Well, I'm going to create a method called public void NQ that accepts an integer v. All right, this allows us to put an integer on our queue. What we'll do is we'll say node. New node is equal to new node v. We don't really handle memory management in this course, so if you read over here, if the queue is full, that it's going to be an overflow condition. I'm assuming that you're not using these queues to store massive amounts of data. If you were, then we would have to obviously include an overflow condition in case we run out of memory, but we're just going to have small queues for now. So let's just focus on what we're doing here. So we first need to check to see if this queue is empty. We can either use an isEmpty method, which we will write at some point, or for now I'll just say if size is 0, which is essentially what the isEmpty method determines. All right, just to make it so that I don't have to write that method first. If size is 0, that means we have nothing in our queue. And if that's the case, we can set our head equal to our new node and our tail equal to our new node, because it's the only node in the line. If you're the only person standing in the line, you are both the front and back of the line. Funny enough. All right. Else. All right. So if it's not empty and you're adding an, you know, when you have no line and you add a person to the line, they become the line. But if a line already exists, that means there's multiple elements there. And so what we have to do is we're just going to set our new node dot previous equal to the tail. So our new node that we created, what happened before it is now the tail. So wherever the back of the line is, that's what it's pointing to. Tail dot next is equal to new node. So whatever was the back of the line is now saying, oh, well, there's someone next behind me, and that's that new node, right? And then our tail becomes the new node. Size plus plus. We're gonna have a video coming out later this week where I do diagrams for all this. So don't worry if it's not super clear right now. I'll go over exactly what I mean for NQ and DQ with diagrams to match it so that you guys can fully understand. But I think we're approaching on 10 minutes now, so why don't we close off this video here. Just make sure you get these things. Make sure that you're submitting your work. A lot of you, if you look in Pupil Path, you'll see you do not have grades in because you don't click that submit button that should appear up here. In fact, if I hit student preview right now, you should see this submit button up here. Please make sure that you're clicking that at the end of every work session so that I can see what it is that you guys are doing. Also, don't forget to complete the attendance form and join the Discord server if you need to ask me any questions. Obviously, you can also message me on PupilPath, but I will be fastest at answering if you message the Discord server, because I can get those messages straight on my mobile device. All right, guys. Yeah. Great work today, and I will see you tomorrow. Bye.